Assalamualaikum. Good morning. Today, on week 3, you're going to do lab module number 2. So we are going to look at lab module number 2. Title interfacing, input and output interfacing with LEDs and switches. So the objective is that by the end of this laboratory briefing and your laboratory work, students should be able to write down C language to program by controlling LEDs using this PIC 16F877A. And then after that, you design a C language program to control and manipulate LEDs and switches using PIC 16F877A. So throughout of this lab session, you need to use this type of PIC. So equipment required would be MPLAB X IDE, XC8 compiler, computer unit, and also the last one PIC SimLab. So you're going to do everything simulation based. So these are the instrument and software that is required. So we look at introduction first. So the first thing item that we need to view is digital input. To be precise, we're going to look at some of the basic introduction for switch. Okay, I will just give you brief introduction only since the subject has been covered in our past lecture. So we use so normally we use switch to give digital signal, to provide signal. Okay, so the type of connection can be pull high or pull low configuration. Based from your previous lecture, it can be active high or active low. So for low, we need we know the switch need to give 0 to the microcontroller. For high, the signal the switch need to give 5 volt or high to the microcontroller. So by connecting the switch to the microcontroller, and then we can program the microcontroller to read the input, whether it is active low, active high. So we need to adjust the coding according to the type or configuration of the switch. Other than switches, we can also include digital sensor such as temperature sensor, humidity sensor, encoder, and so on. So if you refer to figure 2.1, this is figure 2.1. What you see here is a schematic of 3 switches connected to 3 input to the microcontroller. This one indicate connection to the microcontroller, which will happen in port B, starting from bit RB0, bit RB2, and then the last one bit RB2. So KC3, KC2, and KC1 will be connected to their respective switch. Okay, so KC1 will be connected to switch 3, KC2 switch 4, and then the last one KC3 will be connected to switch 5. Okay, so this one naming convention only. You can freely name what the name that you desire. So you can see the supply VCC will be transfer directly to the port B when these switches are not pressed. So if either 1, 2, or 3 being pressed, so the signal here will become 0. So therefore we can say that this type of switches switch configuration, KC1 active low, KC2 active low, and then KC3 active low. So when pressed, initial value high will be changed to 0. So you need to make some kind of adjustment do on the programming side, so that the code could understand active low. And then we're going to look at the output. So for the output, we're going to view LED. Okay, so as you have already learned, the most basic and commonly used output devices in electronic circuit board You can find the application of LED everywhere, starting from instrument, electronic device, and so on, computer, PC, and so on. So we use LED to indicate whether to display the logic high or low from specific microcontroller pin. By connecting an LED to a specific pin, we can observe the output of the microcontroller, whether the signal is producing high or producing low. Same like switches, same like switch, we can also configure whether in either in active high or active low, as shown in figure 2.2 and 2.3. This one. Okay. So for figure 2.2, two type of configuration. This one, the microcontroller need to give high, okay, in order to turn on the LED. So for this case, we call it active high. And then for this one, the microcontroller need to give 0 or low in order to turn on the LED. So since 0, since low, we call it active low. Since high, or we call it active high. So the assumption, just like that, to make the whole thing easy, we just assume, we try to relate. For if high signal, so the conversion must be high. Same goes. If low, then the configuration must be active low. And this is some possible connection. So basically, you can connect multiple number of LEDs to the microcontroller. So for this case, you can see we can start from RA1, RD0 until the last one, RA2. Okay, this one not related. This one for encoder. So this one, resistor will be represented by the resistor pack shown here. Okay, so you can see the configuration here is still active high. Okay, why? Because giving high signal will turn on LED, because going to ground. Okay, do you have any question before we look at exercise example, exercise number 1? Okay, so no problem. So we look at the first one, blink the LEDs. This one very basic program example. So for this program, no input will be required. You just observe the output. So need to connect all LEDs that connected to port D. So we have 8 pin, or 8 pin or 8 bit. So the whole 8 bit need to be connected to the LED. And then the condition must be all LED must blink every 1 second. So the definition is that for blink must be for on must be 500 millisecond, and then off back to 500 millisecond. So total up would be 1 millisecond. And then this is the program. So you can see here we have double slash. So double slash means that the code, the following text here will not affect the coding. So we use it to write any comment, any information related to the program. Okay, same goes for the second line. Okay, another double slash. So this one giving out the information. Okay, what is contained on the third line. And then we go to the configuration of the PIC. Okay, starting with the frequency oscillator, and then the last one, low voltage programming. Okay, we just enable and disable. Okay, according to the PIC 16F877A datasheet. Okay, and then make sure that the crystal oscillator frequency is at 20 megahertz. So everything must be 20. So this one, you refer to peak sim lab. The clock must be 20 megahertz. Okay, must be same. And then from here, we type, no need, okay, no need for the coding. So we just proceed to the main subroutine. Okay, so this one, since we are using port D as output, so we need to configure first the data, the direction register, which is trace D. Okay, so we want all output port D to be configured as output. So all 8 bit all 8 bit must be set as output. Starting from 3D, this one you need to do first before you proceed to the port. Okay, we want to configure whether the port is input or output. And then after that, we go to clear port D okay, by giving out all 0 to the port D. This one we want to clear initial value of port D. And then we go to the continuous looping while true, while the condition is true, do this. Do this code. Starting from port D must be all high. Okay, so all high, this means that to turn on, port D must be giving out high. So the output LED must be in the form of active high configuration. So you turn on port D and then wait for 500 milliseconds and then you turn off, giving the value back to 0, the respective bit back to 0, and then wait for another 500 milliseconds and then you repeat the whole subroutine, the whole code. So that one. Okay, so we look at on the MPLAB side. So the program, the project file has already been created. So I think you should have no problem. If you have problem, you can ask now. So the project has been created already. So if some of you having problem, prefer first lab module, lab briefing number 1. So the step regarding to related to PIC MPLAB has already been explained. So you can see here the project has already been established. So just look at the movement of my cursor. So you can see here, make sure that the debug tool here is PicSimLab. Okay, PicSimLab is available here. And then the compiler must be XC8. And then the microcontroller PIC 16F877A. So we go on to add the C file. Okay. So since I already made the file, so I just add existing item because the file has already been created. So just select, wait for the file to appear here. Okay, double click and then you can see here the content of the main C, the file, the .c file shown here. So you can see we just copy you just copy the whole thing and then you can see from here. Okay, anything that follow after the double line, so you can see the font color different from the code. Okay, so you can see everything has been color coded, so you should have no problem. Okay, the code, the subroutine, they all have their own respective color scheme. And then you can see okay, anything that is gray okay, anything that is gray like here is actually the command. Okay, will not affect the program. Okay, only the active color okay, so you can see here the blue. Okay, the blue and then this one green. Okay, this one will be embedded into the microcontroller. So make sure the clock setting is at 20 megahertz. Okay, this one is quite easy, basic, very basic only, turning on and turning off. And then you go to PicSimLab. Make sure you follow the startup order. Start by double execute MPLAB first, and then you go for once the software has been fully loaded, then you can go for executing PicSimLab. Okay, so this is the LED okay, LED on the PicSim side PicSim side. Okay, so we just connect all the LED to the port D. Okay, so properties if you want to change, if you want to rename, to connect to other port, you need to go to properties. So you can see RD0, RD1, RD2 up to RD7. We want to view all all the bit, all the 8 bit on port D. So we connect all the port D to the LED. So everything is perfectly in order. So if you're confident that your program is working correct, so you can start by building the project. And then looking down, make sure that the status must be build successful. Okay, so green font, build success. So this means that your program will not contain any error. So you can proceed to debug. Okay, so you can see, if your window does not contain PICSIM, wait till the tab appear. Okay, so you can see here. Okay, PICSIM will be available. So you can see run target. So you can go here. Okay, so this is the blinking order on 500 millisecond, off 500 millisecond. So that one we conclude on the exercise 1. And then if you want to modify, you want to move to the next example, you start by turning off the debug section first. Okay, so I will remove this project. If you are doing multiple project, multiple file, you need to remove. Okay, make sure that only one file contained in your project. Okay, why? Because we have this code. Okay, main. If you have two file, and then the two file will contain main subroutine, and then when you run, you will get error. Okay, so you can see here no more file. So we go back to lab briefing. Do you have any question for exercise 1? Ada soalan untuk exercise 1? Okay, no soalan. So we proceed to exercise 2, turning on and turning off specific LED using 2 switches. So this time we're going to concentrate on the specific part, on the specific pin. Okay, by using 2 switches. Okay, so this time we are not going to turn on all of the LED. We just concentrate on the specific pin only. And then we for this time we're going to have input, which is 2 switches. We name it SW1 and SW2. And the output only one pin on, and then the location is located on pin RC2, okay, which is the output. So the condition would be when switch 1 press, LED at RC2 will turn on, and if switch 2 is pressed, the same LED at RC2 will turn off. So you press switch 1, LED RC2 turn on. You press switch 2, LED RC2 will turn off. Okay, so this one already the code has already been separated, been removed on the detail part. So it just show you the main part, the main structure that you need to follow. So we start by the definition. So for this example, we rename pin at RB0 and RB1 as switch 1, SW1 and SW2. So after this, if you want to refer to RB1, we can always write down SW1, and for RB1 we can refer to as SW2. So that one, and then this time, okay, this time you need to configure trace C and also trace B. Okay, trace B need to be configured as input, and trace C need to be configured as output. Okay, port D not included, so you need to remove port D. Okay, so we go to main. So this is the configuration of the direction register. Trace C, okay, we configure as output. So you can see, even though we are using only one bit, okay, which is at RC2, okay, but we clear, we configure all the pin on RC2, okay. This one is also acceptable provided that you are not connecting. Okay, you are not connecting other than RC2 to another load. Okay, if other than RC2 is not connected to any other part, so you can do this. Okay, but if you are connecting to other load, so you need to go for individual configuration like this one. Okay, and then we go for trace B. Trace B, we are going to configure only 2 bit as input, so which is RB0, and then this one RB1. Okay, so this one 1 1. The rest should be 0. Similar like C. Okay, so you can use this type of configuration, this type of format, provided that all the available pin is free, not connected. And then once you have configured, so we are going to configure trace C as output and then trace B as input. So this means that port B will be input, port C will be output. And then the second one, we need to clear any initial value from port C. Okay, so this one just go for the individual, which is RC2. And then we proceed to the continuous looping, whereby switch 1, this one double equal, so you are comparing the value to switch 1. The value is 0. So if SW1 is 0, if the condition is true, you proceed to turning on LED at RC2. If switch 2 is equal to 0, so you can proceed by turning off. That's it. Okay, so the condition here, so you can see, okay. In order for the code here need to be executed, the value for switch 0 must be 0 or low. So this means that the configuration of the input switch is actually active low. Okay, same goes for here. If you are putting this one 1, so this means that the switch configuration must be active high. Okay, so we change first the circuit here. Okay, to exercise number 2. Yes. So you need to concentrate on this part, which is RC2. The rest, just ignore. Okay, so we just want to observe output from RC2, and then the input here. Okay, so you can see the rest not connected. Okay, RB0 and then RB1. So we go back to the MPLAB programming. So double click. You need to add new. Okay, so since I already do this, so I just add. So you can see here. Okay, so you can see here the file already been uploaded. Double click to view the content of this file. So this is the code. Okay, same goes, same code from the module, and then we write it here, and then you need to add the structure, the important structure, which is the first one, and then the clock configuration, and then this one. Okay, so you can see we rename it. We define RB0 as SW1 as RB0, and so on. So okay, make sure PixSimLab here should be PixSimLab, and then the compiler must be XC8. And then if you are confident, you proceed to build project. Wait for build success to appear here. If not success, so error, so you need to go to the code here and then do correction. Okay. Since the status is success, then you can go for debug. Okay. Okay, run target. Okay, you see nothing. Okay, nothing is happening. Why? Because we are not pressing any button yet. In order for LED to turn on, button here must be pressed. So we start by RB0. Okay, so RC2 will turn on here. And then to turn off, we press RB1. Okay, same goes here. Okay, if you press multiple times, nothing happen. Why? Because you need to observe back your coding. The condition only happen when switch RB0 is pressed, it will turn on. Other than that, if you press RB1, it will turn off. Okay, that one. That one we conclude on the briefing for lab exercise number 2. You have any question? Ada soalan?
Betul. Okay.
Okay, tak ada. Ada yang bagi perhatian. We proceed. So this one, we go to continue loading the last one. Loading the last one, exercise 3. And then this one, you need to remove. Okay, double click this one. Okay, we look at exercise number 3. Okay, the exercise number 3 is a little bit complex than the previous one. So you can see, still 2 input, but this time you're going to observe 2 output. This one, the output is LED connected to pin RD0 and also RD1. So you need to connect LED to pin RD0 and also RD1. And then the condition is switch 1 is pressed, LED RD0 will blink 1 time. If switch 2 is pressed, then LED 0 and LED 1 will blink 2 times only. That's it. Okay. RD0 will make the switch 1 press, will make the LED RD0 blink 1 time only. Okay. And then switch 2 will make the LED on RD0 and RD1 blink only 2 times. Okay. This one you can use, you can reuse. Okay, since we are using the same setting. Yeah? Okay, but this time the output must be at port D. So port D is output, so therefore you need to configure 3D as output. Okay, so you just configure all the pin as 0. So this means that it is output. And then we clear output from port D starting from RD0, RD1, RD2. Okay, so you can see RD0, RD1. Okay, another extra here. So this one you can ignore. Okay, this one does not have any effect on the program. Okay, so if you want to ignore, you can always put double slash here. Okay, by putting double slash, so this means that you are disabling the code. Okay, so because we want to only observe RD0 and RD1. Okay, you can go for delete. And then after that, we proceed to continuous looping. Okay. So if while is true, so switch 1, the program will start by comparing switch 1 with 0. And then if switch 1 is true, the condition here is true, then RD0 will be turned on. Okay, for delay 500 milliseconds and then go turn off again. Okay. And then if condition for switch 2, SW2 is true, so need to do blinking 2 times. So you can achieve this by using for loop. Okay, starting from I0 and then the parameter must be I less than 2. So and then I increase. So the initial value is 0. If switch 2 SW2 is true, then you go for loop, start by I equal to 0. So at I equal 0, the first looping, you turn on RD0, you turn on RD1, and then you blink for 500 milliseconds, and then you turn off again, wait for 500 milliseconds, and then you go back. Okay, this time I is 1, then execute the whole code, and then this time 2, the value here is not true, so proceed to continuous looping. Okay, do you have any question before we proceed to MPLAB program? Okay, no question. Again, similar pattern here. For you, you need to write the code. Okay, since I already made the code, so would be efficient. I just reload the code. Okay, select. Okay, rename this with suitable name so that you can identify the correct program. So you can see here the loading, the file has been loaded. Double click. double click, and then the content of this file will be shown here. Okay, so the configuration still remain the same. Okay, with 20 megahertz, and then the input RB0 and then RB1, and then accept this one. Okay, accept this one. Okay, we are using port D as output, so we need to configure trace D as output, and then the rest remain the same. Okay, for trace B, we are similar like the previous one. We are using only two inputs, so the input should be at RB0 and then RB1, and then we clear any initial value from port D. Okay, so start with RD0 and then RD1. So you can see here, okay, what happened when I put double slash. Okay, what if I remove double slash? So you can see the color transition. Okay, if I put double slash, so this means that the color will be gray. So this means that the code here will not have any effect. Okay, so we are disabling this code. And then the rest would be same thing. Okay, we just copy from the lab exercise, and then you just do the same thing. Okay, so make sure every time you do the program, make sure that here is 0. Okay, not O. Okay, make sure you differentiate that between the code here, very case sensitive. Okay, and if SW2, so you can see here, okay, the code here, S capital letter, W capital, and then 2. Okay, so same. Here should also be the same. Okay, if the configuration is shown like this, so the calling also should be similar, because we want to refer to the source. Okay, so should be the same. If you are putting this, writing this differently, then when you want to build, you will have error. Okay, and then recheck. Always recheck. Okay, pick SimLab. X8 compiler, and then this one, XC16F877A. So if you are confident with your skill, so you can proceed to build project. Okay, observe at bottom, make sure that the status is build successful. Okay, build success, and then you go for debug. Okay, observe the bottom. Observe the bottom. Okay, pick sim will appear here. Pick sim. Okay, build success. Build success. Okay, so you can see here. Pick sim will be enabled, and then run target. Okay, you can go for this one. Okay, so the condition is that RB0. Okay, okay, blink one time, and then RB1 two time. Okay, I repeat again. Okay, blink one time, blink two time, and then I repress again RB1, so you can see here. Okay, it doesn't have to follow the order. Okay, any order is okay. Okay, whether you can start by RB0 or you can start by RB1. So you can see here, I start RB1 first. Okay, it will follow any condition that is true. Okay, the program will follow any condition that is true. So you can see here, if you have three case, three condition, so they will be output according to that condition. Okay, so you stop if you want to modify. Okay, stop. Need to stop debugging. Okay, so okay, I think that's it. That's it. That one for lab exercise. So do you have any question? Okay, no question. So we go for submission briefing. Okay, that one already conclude on the exercise part. So we just refer back to this one. The submission one. The one that you need to do. Okay, the previous one you are also required to do, but you need to do it by yourself. Okay, just for knowledge sake. Okay, this one we call it design question. So you need to do design question. This one will not be explained. I will just explain only the question. The answer will not be explained. So you can see here we have up to 3 design parameters. Okay, write a C language program to perform the following tasks. We have up to 3 tasks, whereby task number 1 stated that if the switch 1, which is SW1, is pressed, the LED at port D. So you can see here, throughout task 1, task 2, task 3, you're going to use port D. Okay, port D. And then the LED must be connected to port D. Okay, so the input switch does not indicate where you want to use. You can use port B, you can use port C, you can use port A. Okay? You cannot use port D. Why? Because already full. Okay, because you are connecting all the LED to the port D. So therefore you cannot share. Okay, port D with switch because already full. If not full, then you can share also can. Okay, provided that you configure correctly on the direction register. Okay, we look at task 1. If the switch is W1 is pressed, the LED at port D will do running light from left to right. So you can see here my cursor movement. Okay, the condition must be if you press, the LED will turn on at maybe on the left bit will turn on, and then turn off, and then this following bit turn on, and then the following, and then turn off, and then the following bit up to the final one. Okay, so it will start by turn on, turn off, and then following bit turn on, turn off, and then the following, and then to the rest. Okay, that's it. Okay, only happen when switch 1 is true, SW1. And then for switch 2, SW2, if you press this one, the LED at port D will do running light from right to left. Okay, this one opposite. Opposite. Okay, previous one left to right, this one right to left. And then the last one, you have 3 input, SW3. LED at port D will do running light from right to left, and then return back left to right. Okay, right to left, left to right, right to left. Okay, running light. Back, front, back, front, and so on. Okay, you do this. You need to do this, and you need to submit your report based on this design question. Okay, other exercise not included, not related. So you are only required to do report for this part only. Okay, so once you have completed this one, so you need to write. Okay, this one very important, in handwriting. So you must write manually. Okay, handwriting, no need to type. No need to type. You need to write manually. Okay, either one. Okay, since you have 2 person in one group, so maybe one person do the report and then the other one do the presentation. Okay, for video, that one I will explain later. If one member do the writing or report, the other one maybe can do the report, presentation, demo video. Okay, so your report on the design question here must contain using the following format, starting from 1 up to 6. Okay, so 6, for 6 you need to include front page. So the front page, if you refer to GC, classwork, laboratory, this is the front page. Okay, only on the first page only. Second page, no need, not required. Okay, also included the guideline for lab 2, 3, and 4, and also report guideline for OER. This one, okay, if we want to make changes, we will inform you. Okay, right now this is the condition that we want for OER. However, this one I will brief again after the second half of the semester. But right now you need to concentrate on this one. Okay, so you can see the condition here, the step is quite general. So I would prefer if you could refer to this one, the one that is come together with your module. Okay, so refer to this one. This one is very precise, very detailed. Okay, so for number one, task number 1, you need to fill this cover report. Write down, if you're doing module 2, write down module 2, and then the title must be input and output LED and so on, depending. Refer to the lab module title, and then this one should be your group name. Person number 1, person number 2, their respective metric number. This one must be included with your lab report. Lab 2, lab 3, and then lab 4. And then your report must contain introduction section. Okay, the introduction must be related on the design question only. This one, okay. You no need to put everything. No need to copy. No need to copy from here. No need. Okay. Why? Because you will get 0. Because not related to the criteria. Okay. The introduction must be related to your design question only. Okay. If you copy out the whole thing, the whole introduction on the left side, okay, would be very useless. Okay, because no mark will be awarded since not related to the criteria here. Okay, so the introduction must contain briefing on the design question. And then for methodology, must contain these two items, okay, whereby you need to include schematic, also in handwriting, schematic of the circuit. Okay, so you must start with the PIC. You must correctly label the PIC, which is PIC 16F877A, and then all the pin must be properly connected. Okay, since I already taught you during our lecture, you need to connect MCLR, so you need to include the circuit for MCLR, and then you need to include circuit for power supply, and then you need to include for clock. Okay, that one will be the basic. You need to understand that even though if you're doing this in the exam, everything here must be included. Okay, the 3 items, supply, MCLR, and then the clock. And then after that, you can also the rest is your connection to the LED, the switch, and so on, according to the design question. And make sure to label properly. If switch 1, make sure that you put label switch 1 on your schematic. Okay. If you are not putting any label, that one will be your mark will be affected. Okay, because we don't know where is switch 1, where is switch 2, where is switch 3. Properly labeled. Okay, and then flowchart must be properly labeled and properly written. Start with start, and then initialization, and then if available, decision making. Okay, the pattern for decision making for start, you need to draw that correctly. Okay, make sure that the arrow is pointing on the right direction. Okay, everything here must be in handwriting. And then for number 4, result and discussion. This one, no need for handwriting since you are making a demo video. This one only related to the demo video, okay, and not the discussion and the result part. You still need to, for the result, you just create the demo, and then for the discussion, you need to write discussion regarding on the design question. So other than that, the criteria for number 4 must have a demo video. This one will be your result. Okay, so you need to create a video presentation around 3 minutes. Okay, must not exceed 3 minutes. Okay, 3 minutes. No need to describe everything, just describe the result. Okay, and then the file must be in MP4 format. Okay, so you can start by explaining. Make sure that your video contain your name and then your partner name. Okay, and then you can proceed. No need for introduction. You can proceed for the output part. You can start by explaining the code section, and then you go to MPLab. Okay, explain a little bit, and then you press play. You press build, and then you press debug, and then you go to view. Everything must be properly narrated. Okay, you must explain all the process. Okay, no need not better if you are not making silent. Do not put silent movie. Okay, every action you must narrate it, you must explain. And then you go to the sim lab, make sure that you explain, and then you do the output lah. Okay, what happen if you press this one? Okay, the output will be here and so on lah. Okay, so you are also required to explain. Okay, so the whole duration must not be more than 3 minutes. And then for criteria number 5, you need to put down the conclusion related to the discussion. And then the last one, appendix must contain the program from the design question here. Okay, the program must be coming from MPLab. Okay, so this means that you need to follow structure. You need to start from the first structure, and then the main, and then the last one, depending on the code. So this one must come from the MPLab. Okay, so explain again. The criteria must be handwritten, and then the report must be scanned. We prefer PDF version, and then uploaded to Google Classroom. Okay, this one is just the alternative. However, okay, since our coordinator has prepared a link, so you just go to this link. Okay, go to this link. Okay, but before that, we look at the second criteria here. Video demo should be uploaded via sharing a link in group member respective drive or Google Classroom. Okay, if available lah. Okay, if not, you can also I explain this one first. Once you have created the video, you can put that video in your individual drive, in your drive, and then you must share. Okay, enable the sharing. Okay, enable the sharing with me so that I can view your video. Okay, enable the sharing, and then the link. Okay, you must complete at this form. And also, once you have write down your report, okay, your report must contain the link of your video. Okay, need to include the link of your video demo in your report. Okay, do not put other than your drive. Okay, YouTube drive also acceptable lah. Okay, but we prefer in your own drive. Make sure that we can access. I can access your video. I can view your video. And then once you have already completed the following task, okay, you have successfully uploaded the report, the video, you can register the video link by completing the attached form link. Here, this one, okay. You just click here, and then you will be, okay, and then you will be directed to the form here. Okay, this one for lab 2. Okay, put down your name, your partner, and then this one extra case if you have third member. Okay, the third one. Okay, this one permission from coordinator, must obtain permission from coordinator. Okay, normal case would be only 2 person per group, and then lecture group, okay, either G1, G2 or G3. Of course, it should be G2 lah. Okay, and then this one you need to upload. Okay, your report, lab report. Okay, lab report 2 Okay, lab report 2. Add the file, and then this one will be the link for your presentation video. Okay, once you have completed all the section here, you go for submit. Okay, so this one very important. Okay, you are required to complete your report within 1 week. Okay, so this one 15, so 22 should be next week, next Friday. Okay, so make sure you follow the deadline. Do not submit after 22, after 22nd, because it will affect your mark, okay, your laboratory mark. Okay, we prefer that you submit early, okay, and do not submit after 22nd, because try to avoid submission, late submission. Okay, 1 week only. So do you have any question you want to ask? I think I already explained everything. If you have any question you want to ask? Okay, ada soalan you want to ask before we stop?